Physics Challenge 7, Alternate Current. Now this is pretty hard one. Tell you the reason. Its step function is easy. It's just like turn on the switch. But this problem we can solve for any other sine wave voltage source or impulse, whichever. So what's happened is it's asking V1 here. So that means V2 and V equals V1 plus V2. Okay, the V2 is actually L di dt, and I flow two different locations. I is C V1 dt plus V1 R. So you take a derivative again, it's going to be V1 plus L over R V1 prime plus LC V1 double prime. So we clean up this, you notice that it's going to be V1 double prime plus CR 1 V1 prime plus LC 1 V1 equals VLC. It's a forced oscillation, and since this forcing function is simple, it's going to be attenuation. So in the oscillation section you run this. So here lambda is going to be 2 LC 1 CR, I'm sorry, CR, this guy, right? And n square equals 1 over LC. So omega is actually minus 4C square R square. Now the condition, one of condition is that this is larger than L. Well, in another word, 4C square R square is larger than C L. Okay, so this is larger, that means this is gonna be ignored, and the omega will be simple 1 LC. Okay, so only things remaining in this solution is to determine K, A, and B. Okay, so if you look at the circuit, if time is infinite, it's settled after attenuation. Once it's settled, no more current here, so we can ignore this. Then this doesn't act any, it's like a short circuit. So it's going to be the V applied to R. So when t is infinite, then this portion is going to be 0. So X equals V. Now, next, when t is 0, is suddenly you apply the volt. This guy refuses to flow any current. You take entire volt V. That means this guy is at 0 here. V1 is 0. So when t is 0, V1 is 0. And that means K minus t is 0 is this is 1, and this disappear. B equals 0. So B is minus K, which is minus volt V. Okay. Now we look at what's happening in the beginning. This V1 is 0, and V1 is when V1 is 0, the current is 0. The current of the capacitor is C dV1 dt, right? Okay, so the current is 0. We take a derivative of this, okay? Then A omega cos plus B omega negative sine plus A sine omega t plus B cos omega t and minus lambda. Okay, so that's going to be 0 when t is 0. So t is 0, this disappear, and this is going to be 1. So the remaining is A omega minus lambda b equals 0. Since we know the b, the A is lambda b over omega. Okay, so we got the answer. All the constant determined, and we know the omega, and we know the lambda, which is attenuation constant. Okay, so that's gonna be the answer for this question. I hope you enjoyed this video, and please check others, and if you like, subscribe.